section 7.3. We're kind of shifting gears a little bit here. So it's a little bit different deal because we're getting ready to do addition and subtraction. And the bad thing is multiplying and dividing fractions are easier than adding and subtracting fractions. So we are shifting into addition and subtraction, but this is actually a little bit more difficult because, does anybody remember what you have to have before you can add and subtract fractions?
Common denominator.
You have to have a common denominator. The denominator has to be the same, and once it's the same, you just add the top together or subtract the top, whatever it is. But that's the difficult part, is trying to get those denominators to be the same. Okay, or it can be the difficult part. So just like with fractions, the least common denominator, or the LCD, is very important to working with rational expressions, because we want to find the smallest denominator that will work as the common denominator, so that we don't have gigantic numbers that are way bigger than they need to be. So the process we use to find the least common denominator is based on the process that we use to find the least common denominator with integers. And again, that's going way back to chapter 0. And yeah, I don't know if we spent tons of time on it that day because I knew that we could use our calculators to help us out with numbers. Unfortunately, calculators don't do these, so we've got to do some work here. So I'm going to kind of reintroduce this, and let's take a look at 8 and 6. If we write down 8 and 6, and we write out their prime factorizations, so how can we break up 8 and write it down with prime factors? 2 times 4, and that would be 2 times 2. So 2 times 2 times 2. Okay? We can also think of this as a least common multiple. It's the same word, except we're going to be using this as denominators. And then 6 is pretty easy. How do we break that up? 2 times 3. Okay, so here's how you find the least common denominator or the least common multiple. It's the same process. You look up here and you say, okay, we've got 2's. And there are some 2's up here and there's a 2 down here. Whatever the largest number of 2's is, you have to use that in your least common denominator. So because there are 3 2's up there, we've got to use 3 2's in our least common denominator. Okay. Then we've also got 3's involved. What's the biggest number of 3's that we have? 1. There's just 1 right here. We have to use that in our least common denominator. Once you have chosen the largest number of each individual factor, you're ready to go. So again, with the variables, we'll just leave it written in factored form. But here we would take 2 times 2 times 2 times 3, and our least common denominator would be 24. Okay, so we break it up into its factors still, and then we choose the most of each factor. Okay, so the idea, and what I try to tell my students in school when we're doing this is, I should be able to find, if I've got 3 2's right there, I should be able to find 3 2's in my common denominator. Okay, in the second one, if I've got a 2 and a 3 here, I should be able to find a 2 and, now they don't have to be next to each other, they were in this case, but I should be able to find a 2 and a 3 in my common denominator. Okay, that way you know you've got everything from either one. All right, so that's the first one. That's an example with numbers, and I know we kind of skipped over that. At least I think we probably did way back in August or whenever we started. And I probably should have asked if there were any questions before I erased that, but too late now. All right, so then what happens if we go back to like chapter 5 type problems? There's no addition or subtraction still, but we've got variables and exponents and things. So 4x squared y to the 5th, and what do we got here? 6x to the 4th y cubed z to the 6th. All right, let's break this up. Do we see that this is 4 is 2 times 2? And then again, I'm going to write it out. You don't have to do this every time, but just so we can visually see it. There's 2 x's and there's 5 y's. Is everybody okay with that first one? Is there a glare? Sorry. But 4 is 2 times 2, x squared is 2x's, and then y to the 5th is 5x's, and that's all multiplied together. With the 6, we just did that. That's 2 times 3, and this time we have 4x's, and we have 3y's, and we have 6z's. Okay, that means our LCD, or again, could be the LCM, least common multiple or least common denominator, has to have the most of each thing. So we start out just at the beginning, we've got 2's. How many 2's do we need to have? 2 of them, because you see there are 2 2's up here. Okay, that's the most number of 2's. Then we look at, we've got 3's. How many 3's do we have to have? 1 3, because there's a 3 down here. Then we look at the x's. What's the most number of x's that we have? X to the 4th. It's this right here. And then we look at the y's. What's the biggest number of y's that we have? 5 from right up here. And then we have z's finally. And what is the most number of z's that we have? Well, we only have them down here, right? So there's 6 of them. And that's why I say you don't have to actually write these out every time, but just, again, so we can visually see it. So what would we get when we put this back together? 2 times 2 times 3 is 12. And then notice we have x to the 4th. We have y to the 5th. And we have z to the 6th. And that would be our least common multiple or least common denominator. Okay, now I want you to look at one thing here. Notice when you look at the x to the 4th, the y to the 5th, and the z to the 6th. Notice we actually see x to the 4th, y to the 5th, and z to the 6th. Right? With x's and y's, with the ones that have exponents, it's really easy to choose. You just look at the x's and you say, okay, which one is the bigger exponent? That's the one we need. And we look here at the y's. Which one is the bigger exponent? That's the one we need. And you look at the z's and you say, which one is the bigger exponent? That's the one we need. So the numbers are actually the hardest parts. The x's and the z's are actually easier. The variables. Okay, if it's just a variable to a power. I'm going to be smart this time. Are there any questions on this before I erase it? This same process that we're using, that's what we're going to be doing with those ones that we have to factor. Okay, so we're going to get more factoring practice. Yes! All right, so let's try these two. All right. And I'm just going to factor these right here. So to factor this first one, we multiply 1 times -3, and that gives us -3. And since it is a negative, what does that tell us about the signs of the numbers that we're looking for?
Opposite.
Yeah, one is positive, one is negative.
2 times 3 times 1.
And then, and you're right, you're just ahead of me. Since that's a positive, what does that tell us?
Positive is larger.
The positive one has to be bigger, because when you add them together, you get a positive answer. So when we write down our possibilities, and 3 again is prime, so there's not many options, we need the positive one to be bigger, so -1 and +3. Does that add up to be 2?
Yes.
Yes. So that means x squared plus 2x minus 3 can be factored into what two factors? Using our shortcut again, because this is just an x squared. What are the two factors going to be?
Negative x minus 1.
X minus 1 and
X plus 3.
x plus 3. That's correct. Okay. Now looking at the next one. So now we're going to factor this one. Multiply this times this. We get 1 times -12 is -12. And once again, we look at our signs. And since this is a negative, what does that tell us about the signs of the two numbers we're looking for?
Opposite.
Yeah, one is going to be positive, one's going to be negative. Once we know that they're different, they have to add up to be a negative one. So what does that tell us?
The biggest one is negative.
The bigger one is negative. I'm almost glad you guys are starting to get bored with that factoring because it means you're understanding it, at least hopefully. Hopefully that's what it means. All right, so the bigger one's negative. Positive 1 and negative 12. Does that add up to be negative 1?
No.
No, right? That's negative 11. 2 times negative 6. Does 2 and negative 6 add up to be negative 1?
No.
No. The next option is 3 times negative 4. Does that add up to be negative 1?
Yes.
Yes. So those are the two we're going to use. And again, we're happy because we get to use our shortcut. So we know that x squared minus x minus 12 is equal to what two factors? X plus 3 and x minus 4. All right. So now that we've got the factoring done, we're ready to do our LCD, or again, we can call this an LCM since we're not really dealing with fractions yet. Okay, so we have to look at each factor individually. We've got an x minus 1. What is the largest number of x minus 1s that we have? It's going to sound like a trick question, but it's really not supposed to be. There's only one, right? There is one x minus 1 from right here. Okay, we've also got an x plus 3. What's the largest number of x plus 3s that we have?
2.
And we have to be careful. It's the largest number of x plus 3s in one individual group, right? We're only
Just
looking at
one.
one group at a time. So this one has 1, and this one has 1, so we need to have 1,
Okay.
right? Remember how we were comparing before? And if there were like 3 up here and only 1 down here, we just took the bigger amount? Okay, well, in this case, the bigger amount is just 1. It doesn't matter which one we get it from. So we're going to write down 1 x plus 3. And that is, I'm going to like squiggle these because they happen to be the same in both. Okay. And then we have an x minus 4. And what's the largest amount of x minus 4s that we have? 1. And again, do not multiply this out. If the computer wants you to multiply it out, ignore it because I don't want you to multiply it out. And I'm the boss of the computer. So, okay. And then we're done because we have taken care of everything that we've got. Now, remember what I said that I tell my students in school? I should be able to find these two factors in our common denominator. And notice I can see them right here. Right? X minus 1 and x plus 3. I should also be able to look at this one and find these factors in here. And notice I can see them right here. And again, they're not always right next to each other, but we can see them both. Okay. So that is our least common denominator. And again, we want the least one because that's going to keep the numbers smaller and the fractions less complicated. Okay. Are there any questions on that one? I know the factoring can get tiring sometimes, but. All right, well, let's go on then. Let's go ahead and do this. 1 times 25 is 25. And let me write this down over here. X squared minus 10x plus 25. And x squared minus 14x plus 45. Okay, so we're going to factor this one first. What does it mean to us that this 25 is a positive? What does it mean about our signs of the numbers we're looking
They
for?
have to be positive or negative.
Yeah, they're either both positive or both negative. Okay? Then, when we look over here, after we know that, what does this tell us?
They have to be negative.
They're both negative. Okay, so when we write down our options, we're going to only do negative numbers. So we have a -1 and a -25. Does that add up to be -10?
No.
Nope. 2 does not divide into 25. 3 does not divide into 25. 4 does not divide into 25. 5 does divide into 25 5 times. Does that add up to be negative 10? And hopefully the answer is yes, because we're out of numbers.
Yes.
And yes, it does. So again, since this is just an x squared, we can use our shortcut. And what are the two factors going to be? X minus 5 and x minus 5 again. Okay. Then let's do the other one. Is everybody okay with that? The x minus 5 and the x minus 5? Do the other one. 1 times 45 is 45. And again, we can go through our thinking process to make sure we get the right types of numbers. This is a positive 45. What does that tell us about the signs of the numbers we're looking for? The signs are the same, either both positive or both negative. Once we know that, we know they have to add up to be negative 14. So that tells us what? It's going to tell us they're both negative, right? Because a positive plus a positive won't give you a negative 14. So they both have to be negative. So if we go through our numbers, and again, if you know your multiplication facts, you might be able to jump to the answer right away, but let's pretend we don't. Negative 1 and negative 45 does not add up to be negative 14. 2 will not divide into that. 3 does 15 times. Does that add up to be negative 14?
No.
Nope. 4 does not divide into that. 5 does 9 times. Does that add up to be negative 14?
Yes.
Yes. So again, shortcut method, we can just put x minus 5 and x minus 9. We've got it factored. We can go to our LCD or LCM. And we've got x minus 5. How many what is the largest number of x minus 5s that we have in one of these?
What is the what?
What is the largest number of x minus 5s that we have in one of those?
2.
2, because there's 2 of them right here, correct?
Mm-hmm.
So x minus 5 and x minus 5 again. Okay, so we've got our x minus 5s taken care of. We've also got an x minus 9. What is the largest number of x minus 9s that we see there?
1.
Just 1. And once we've dealt with all of those factors, we're done. And that is our least common denominator if we're dealing with fractions, or our least common multiple for those two.
That's the answer?
That's the answer. And again, don't multiply back out. Just leave it factored. Okay. Any questions there? Okay. Now, we have been working on finding the least common denominator. Once we know what the least common denominator is, then our job becomes, we've got to change the denominator that we have into that least common denominator. Okay, so we're going to practice doing that without 2 separate fractions, but just with 1 fraction. So here's the fraction that we have. 5a over 3a squared b. Okay. Now our goal on this problem is to rewrite this fraction so that its denominator is 6a to the 5th b cubed. So does that make sense? We want to take this denominator and do something to it so that we turn it into, we need to take this fraction and do something to it so that it now has a denominator of this, but is still equal to what we started with. Okay? And here's the process that we go through. In order to make a 3 into a 6, what do we need to multiply by?
2.
A 2. So that's a lot of times pretty easy to figure out the number. If we multiply by a 2 on the bottom of our fraction, we also have to multiply by a 2 on the top of our fraction. And that's the key here. Whatever we do to the denominator with multiplication, we have to also do to the numerator, and I'm going to show you why in just a minute. Okay? So think about your rules of exponents. If I already have an a squared, what would I have to multiply that by to make it into a to the 5th power? I've already got a squared, but I want to get to a to the 5th power.
3.
A cubed, right? We've already got 2 a's, but we need 5, so we need to multiply by 3 more of them.
Mm-hmm.
So we're going to multiply by a cubed on the bottom, which means we also have to multiply by a cubed on the top. And then for the b's, what would I have to multiply b by to make it into b cubed? So I've got 1. I need to get 3. How many more do I need to multiply by? 2. Because I've already got 1, and I need to get to 3. That makes sense? Because this is automatically a 1 there. So b squared and b squared. Okay? So let's go ahead and now multiply the top. So if I multiply these bottoms together, I will get this. That's how we chose these numbers. If we multiply the top, 5 times the 2 is 10, right? A times a cubed is going to be what? Because remember, that's a 1. So a times a cubed will be
A to the 4th.
a to the 4th. Because you have 4 of them now. Right? Remember our rule for exponents? You add the exponents. Okay? And then we don't have any b's, so if we just multiply by b squared, we just put the b squared here. Okay? So this fraction is equal to this fraction, but this fraction has the denominator that we need to have. Okay? Now, why is it okay for us to do this? Well, notice we're multiplying, right? And we're multiplying by this very special fraction. We didn't draw the line between it, but we're actually multiplying by this very special fraction that we chose. But what is this fraction equal to?
0.
Not 0, but 1. Does that make sense? Anything divided by itself is equal to 1. And what happens when you multiply by 1? The value doesn't change. The value doesn't change, does it? 17 times 1, 17. Negative 32 times 1, negative 32. So we're multiplying by a special form of 1 that will get us where we need to be. Okay? You can scoot over as far as you want if you'd rather be further over.
Oh, no, just the light.
There's a glare. The glare is worse tonight. Okay? So that's the process that we're going to go through. So anytime they ask you to change the denominator or you figure out that you have to change the denominator, this is how we do it. We figure out what we need to multiply the denominator by to get our common denominator, and then we have to multiply the numerator and the denominator by that value so that we're not changing the value of the whole thing. So our fraction at the end is still equal to the fraction we had at the beginning. Okay? And that's the first one we've seen about with that one. So let's take a look. Are there any questions that anybody has about that problem? I think we probably got a couple more, but we'll start with that one. Okay. Well, let's go on then. All right, I'm going to help us out on this one, and I'm going to go ahead and factor this one right here. This one in factored, remember how I said to factor it and leave it in factored form? This one right here, your first step would be factor it. And in factored form, this would be +3 and +4. Okay, so I'm going to give you that right now for this one because I think we've done a lot of factoring. So that would be the factored form. So we want to take x minus 2 over x plus 4 and turn it into something over x plus 3 times x plus 4. Okay, so this is going to be our goal. And once we see that, hopefully it makes it fairly easy, but we'll see. So let me wait till I get everybody done writing. So once we see it in factored form, and we know we already have x plus 4, what would we have to multiply x plus 4 by to turn it into this?
X plus 3.
Yeah, x plus 3. It's once you see it in factored form, it shouldn't hopefully be very hard. We've already got the x plus 4. We need to get the x plus 3. So we need to multiply by x plus 3. And we have to do the same thing on the top. Multiply by x plus 3. Okay? So when we do that, and again, for right now, we're not going to multiply these out. So our answer would be x minus 2 times x plus 3. And again, the reason we can do that is because this fraction that we're multiplying by is equal to 1. Right? X plus 3 over x plus 3 is equal to 1. And so we would get this. Now, I will tell you, eventually, we're going to multiply the numerator out. We're not going to multiply the denominator out, but we will multiply the numerator because when we need to add or subtract, we need to simplify this. Okay, but for right now, we're just trying to get that common denominator or change the denominator. And so that's it. Okay, does that make sense? So whatever we multiply the denominator by, we multiply the numerator by the same thing. All right, well, let's go on.
My brain is not working today.
Your brain is not working? It's a good thing we're recording it then.
Yeah.
So your brain can
I'm
work.
gonna
Your
have to-
brain can
yeah.
work later on. Okay, so rewrite the fractions so that they have a common denominator. Okay, rewrite the fractions so they have a common denominator. So let's look at our denominators, and we've done this before. So this first part is not going to be new. Let's look at the 4b cubed c and the 6a squared b. And let's think about, what is this one made up of? Well, it's a 4. We've done 4 before. 4 is 2 times 2. And then I'm gonna write them out again, I guess. 3 b's and a c. 6 we've done before also. It's 2 times 3. And then we have 2 a's and a b. Okay, so let's find our least common denominator. And this time I am going to leave it as denominator because we are working with fractions. So we're actually dealing with denominators. Do you remember how we do it? How do we choose? We look at the first, we've got 2's, right? And we think to ourselves, okay, what's the largest number of 2's that we see in one of these groups? And we have 2 of them. Okay, then we've got 3's. And we've got 1, 3. Then we'll go, I'm going to go in alphabetical order. I've got A's. What's the largest number of A's that we have?
2.
2. Okay, then we've got B's. What's the largest number of B's that we have? 3. And then we've got C's. And what's the largest number of C's that we have? Yeah, just 1. So if we put this all back together, our least common denominator will be 2 times 2 times 3, that's 12. A squared, B cubed, and C. And again, the faster you recognize this, A squared is the biggest exponent there, B cubed is the biggest exponent, and C is the biggest, or C to the first is the biggest exponent. That means you don't have to write out all those A's, B's, and C's. You just pick the bigger one, biggest one. Okay, so we're partway done. What we want to do is now take these two denominators and make them into denominators that have 12 a squared b cubed c as their denominators. And we'll start with this one. Okay. Now, what do we have to multiply 4 by to make it into a 12?
3.
3. So we're going to do that on the bottom in the denominator and on the top in the numerator. Now notice there's no a's down here. So what do I have to multiply to get a squared? If I don't have any, but I need to have a squared, we have to multiply by a squared. Does that make sense? So multiply by a squared and a squared. And then we have b cubed. What do we have to multiply by to get b cubed?
B.
We've already got b cubed. What do we have to multiply by to get b cubed? Nothing, right? We've already got b cubed, right? And then we've got c. What do we have to multiply by to get c? Nothing, because we've already got it. Okay. Now again, if you've done the work of writing this out, let me show you what happens here. Notice we've got a 2, a 2, and a 3. You can see that you're missing a 3 up here, right? For the common denominator. You've got 2 a's down here. We don't have any a's. We need 2 a's up there. 3 b's, and a c and a c. So that tells us what we need to multiply by to get this into the common denominator. If you just look at what's missing once it's already factored out. If you don't want to do that, that's fine. This way is just fine as well. Let's go ahead and multiply the top. What do we get? 5 times 3?
15.
15. And then a times a squared. A, not 4. It'd be 3. Okay. That makes sense?
Okay.
So then we go to the other one. So we've done this one. Now we go to the other one. We've got a 6. What do we multiply the 6 by in order to get a 12?
2.
A 2. And we have to do the same thing on the top. What do we multiply a squared by to get a squared?
8.
Nope. We don't need anything, right? We've already got a squared, so we don't need to multiply by anything there. That make sense?
Yes.
No? Your brain's not working tonight?
No,
Okay.
it's okay though. I'll watch it.
You'll watch it?
I know.
All right. If you've already got the a squared, you don't have to multiply by anything to get it. You've already got it.
Because you don't need to. Okay.
Yeah. Because we're trying to turn this into this. So if we've already got the a squared, we don't
Okay.
need it. Now we need to get b cubed. What do we have to multiply b by to get b cubed?
3. I mean.
Because remember, this is 1b already.
2.
And
Just
we need
for-
2 more b's.
Yeah.
So b squared?
Yeah.
Okay. And then we don't have any c's, but we need to get 1 c. So what do we have to multiply by? If we don't have any, but we need to get 1.
So you only pay attention to the bottom of the equation?
Yep. Because we're changing the denominator into so that the denominators are the same. The top just happens automatically as we get this one and this one to be the same.
Okay.
Okay. So when we multiply this top, we're going to have 3 times 2 is 6. I guess I'm using green. B squared. And c times c is c to what power?
Square.
C times c will be c squared. Okay. So now notice this fraction and this fraction have the same denominator. And this first fraction is equal to this first fraction, and this second fraction is equal to this second fraction. Okay? Now again, most of the ones we deal with, this is like a chapter 5 question. We're going to be dealing more with the factoring ones, which you may find easier, you may find more difficult, not sure, just kind of depends. So if you need to look at that for a minute, what questions do you have? You have to watch it again too?
I'm just gonna have to watch it.
All right. Well, let's go ahead and try one of these from this section and see how this goes. Because really, this is the hardest part. That's why we do this in a completely different section, or that's why I'm guessing they set this up, just do it in a completely different section. The hardest part of adding and subtracting is getting the common denominator. So we've got a whole lesson just on getting the common denominator. Okay. again, with these, I think I'm going to give you the factorization. So this first one, factors, and it's going to be x minus 6 and x plus 1. Okay. And the second one will factor, and it'll be x plus 3 and x plus 1. So I will write that down for you as the factors. So let's see if we can come over here and find, looking at those, see if we can find the least common denominator that we need. So I'm just going to go in order. I see an x minus 6. What's the largest number of x minus 6s that we see in either of these denominators? Just one of them. So x minus 6 will be part of our denominator. I see an x plus 1. What is the largest number of x plus 1s that we see in any one of these denominators?
2.
But don't put them together. In this one we see 1, and in this one we see 1. So the biggest number of them is 1. Okay? We're not combining them as a big group. We're looking at each one individually. Okay, so there's 1 here, there's 1 here, so the largest number of them is there's 1. And then we've got that, we've got that, we've got that. X plus 3. What is the largest number of x plus 3s that we see?
1.
Yeah, 1. So this right here is going to be our common denominator. So we're going to change these fractions into denominators, or into new fractions that have this denominator. X minus 6, x plus 1, x plus 3, and then x minus 6, x plus 1, x minus 3. Okay. So, looking at this denominator right here, what do we have to multiply this denominator by to turn it into this denominator? And this is where sometimes I'll actually underline. So if this is the denominator I already have, what do I need to multiply by to make this into this?
X plus 3.
You see how we're missing the x plus 3 up here? So we would multiply by x plus 3. And whatever we multiply the bottom by, we have to multiply the top by as well. Yeah. So if we've already got the x minus 6 and we've already got the x plus 1, the one we're missing is this one. That's what we need to multiply by. That's maybe easier to see with these sorts of factors.
Is it x plus 3, right?
Oh, yeah. I changed that to a minus y. Can you talk about this one?
Yeah.
Yeah, that should be a plus. Okay. And so, again, when we do this, we would have 5x times x plus 3 today. For right now, we're not going to multiply that out. When we get to the next section, we will go ahead and multiply that out. Looking at this one, knowing that we already have x plus 3 and x plus 1, what do we need to multiply by to turn this denominator into this one?
2.
We've already got x plus 3 and x plus 1. What do we have to multiply by to turn it into this? We're missing the x minus 6, right? We've already got this.
Okay.
We've already got that. We need this one.
Mm-hmm.
So we multiply by x minus 6, top and bottom. So again, at this point, I would just leave this as x minus 2 times x minus 6. So now, again, this fraction is equal to this one. This fraction is equal to this one. And they have a common denominator. Well, we're not going to do that yet, but yes, eventually we could. We're just, right now, we're just getting them so they have a common denominator.
That's all.
That's all for section 7.3. Okay. And we will be getting more practice on the next lesson doing this. So. Any questions on that before? Looks like people are still writing, so I'm going to wait.
The answer will be the LCD.
Once we figure out this LCD, that's going to be our denominator for both of them, because that's what this stands for, is least common denominator. So we're going to take that and put it as the denominator of both. And then we're going to figure out what do we have to multiply this denominator by to turn it into this denominator. And they're always, well, there's not always, but usually there's something missing here that we need to multiply by to turn it into this. Sometimes one of them will have everything it needs and you don't do anything to it. And then the other one has to be changed. But a lot of times you have to do something to both of them. Okay. And I think that's it. So we've got 7 problems like that where we're finding common denominators or changing denominators.